All right, my name is Brandon Gogetap, and today we're going to look at some alternatives to using fragments. So first, what exactly are fragments? According to Google's docs, they represent a behavior or portion of user interface in an activity. They are used to compose a modular UI. One fragment may only be a small piece of what the user sees on the screen. They receive lifecycle callbacks to allow state saving. And their big benefit that Google says is they're meant to be reusable across different activities. The FragmentManager is what maintains the backstack or the navigation history for you. It allows you to replace or remove fragments to the UI. And it can be used to find fragments in the backstack. So if we look at some of the suggestions that Google says on how to use fragments, if your activity needs to call a method in a fragment, it can acquire an instance of it by using find fragment by ID or by tag on the FragmentManager. Obviously that just returns a fragment, so you do have to cast it. You have to know what you're looking for, which I suppose isn't too terrible, but I think avoiding casting when possible is nice. In some cases you might need a fragment to talk to the activity, and in that case they recommend you create an interface that your activity implements. And your activity should be the glue between fragments, so if you have two fragments that need to talk to each other, they should be going through the activity and not directly to each other. And this is all to maintain the reusability across other activities if that's something that you take advantage of. So here's how Google suggests setting up the interface for your fragment to communicate to your activity. And like I said before, I think casting, especially to an interface, is just kind of losing the advantage we have with type-safe language. So here on attach, the context is always your activity, so you know it's going to be an activity, but you do have to cast it to the interface that hopefully your activity implements, otherwise you'll throw a runtime exception. And anytime you can have compile time safety, I think you should take advantage of, and especially when using interfaces, I think this is a pattern we can easily avoid. So this isn't really a knock on fragments specifically, but just saying that just because Google Docs tell you how to do something doesn't mean it's the only or even the best way. They're trying to keep the kind of fragment and activity file structure simple. Obviously they're not going to go into MVP or any other kinds of architectures in their docs. So this is how you would do that, but in my opinion it's definitely not the best way. So here is another benefit of fragments, or so what Google says. You can have dynamic layouts. So in a tablet you can have one fragment displaying a list of items and another displaying the details, whereas on a handset or a skinnier device you can have each fragment be independent activities. So what this diagram tells me is that activity A should coordinate communication between A and B, because if B needs to talk to A or the other way around, they say go through the activity. So our activity A has logic tied to fragment B. Well, on a phone, activity B contains fragment B, so it would have to contain the same logic and dispatch it however it sees fit. So essentially we have two activities that contain logic tied to fragment B. The fragment may be reusable, but the activities are closely tied to them, and that's another pattern that I think can be avoided. This can lead to not necessarily God activities, but lead you down the path to where you have this logic here. Well, why would I move this other logic out when it's so closely tied to the logic to my fragment? So I just think it sets you down the wrong path. So this was the first slide describing fragments, and I think we can change one word and lose nothing. And what are views? They are a portion of user interface in an activity. They're used to compose modular UI, and they receive lifecycle callbacks. And I don't know why they're not meant to be, but they can easily be reused across activities or in different view groups. So views have been around since the beginning of Android. They make perfectly suitable building blocks for your UI. So if we go down the path of just using views as our base blocks, no fragments, no other container that's wrapping views besides other views, some pros are simple lifecycle. We just have on attached to window, on detached from window, and then save and restore instance state. I think it promotes the use of a presenter. There's no reason you couldn't use a presenter with an activity as your view or a fragment as your view. But because activities and fragments receive callbacks like on activity result and on permission result, things like that, I think, again, they kind of maybe get you comfortable with doing business logic inside them, which can lead you down the wrong path. Some cons, and they're quite big, admittedly, no backstack API provided for you. So you have no built-in way to manage view-to-view navigation, especially maintaining a backstack. So some of the positives of building your own backstack management solution, though, are you get full control over the API, and this is an API you could be using potentially for years. You know when events are going to happen. This is kind of a knock on Fragment API because there are many asynchronous callbacks and you can't guarantee in what order some of the lifecycle events are going to be called. You can't do certain things after like a fourth lifecycle event. You can learn it, but why? I don't understand why it needs to be that complicated, and it really doesn't. An illegal state exception is the big one. If you ever search for fragment issues, you will definitely find a lot of questions on that. And as with any in-house API, updates are under your control. If something's not working the way it should or working the way it needs to, you can change it. So this is a side note that I stumbled upon while looking at fragments a while back. And basically what happened was the settings activity inflated a preference fragment, but it did that using reflection, and it got the preference fragment name from an intent extra. So what these researchers were able to do was supply the settings app with an intent that supplied a different fragment that the app contained, and was able to get the settings activity to inflate the user reset pin fragment, completely bypassing the confirm your pin fragment because all it had to do was put the name of the reset pin fragment in the intent, and the settings activity happily inflated it. And Google's fix for that was to add a protected method called isValidFragment, which you had to override in your preference fragment and return true to prevent some arbitrary fragments in your app from being loaded. And this is a very specific case, but it just goes to show when something is out of your control that doesn't need to be out of your control, you're kind of at the mercy of the framework being updated. So back to using custom views as the building blocks. If you're just doing a quick app, especially one or two screens, it's probably not the best choice, though you could make a library that handles or that implements this backstack for you that you can reuse across apps, and that would obviously cut down on future apps' startup time. So there's a longer initial implementation since you have to build that all yourself, and that comes with all boilerplate. So all three of these are basically saying the same thing. It just takes longer to get going when you have to implement something like that from scratch. Just to go in a little more detail, the backstack class would just be a class that holds a set of objects, and the activity would attach to a presenter type class that just has these methods that other areas of your app will call to either add something to the backstack, remove it, find something. So it's basically a very specialized presenter that's just in charge of UI management. The activity itself would implement those methods obviously and be in charge of inflating the views and performing animations what have you. So again, the backstack has the set of objects defining how to inflate a view. So basically they could have a create view method that takes in a context and it would return for that specific backstack item whatever view you needed to inflate using that context, which would be provided by the activity. They can also define things such as your dependency injection scope. So this makes it really easy to handle scopes with dependency injection, because as you add something to your backstack, you build on your previous scope with your new scope. And then when you pop that backstack item, you can just say, hey, what's your scope? Destroy that. And having those things coupled together makes it really easy to manage your dependency injection scopes. Ideally, the entire backstack could be rebuilt from a bundle. So if your app is killed in the background, you have access always to that activity bundle, and that could be used to rebuild your backstack. And it would probably have to use some sort of reflection, but when rebuilding, that's not a bad thing. And I'm pretty sure that's how FragmentManager works and some of the other libraries we'll talk about in a sec here. So the UI manager, or whatever you want to call it, would be that specialized presenter that's attached to the activity. It would, in one class, when you had to go to a detail screen, it would say UI manager push new details layout or screen, and your activity would be able to create the view, do the animation, and whatever else you needed to do. So it's the interface for interacting with your backstack throughout your app. So if you don't want to do everything from scratch, there are quite a few libraries out there to help you, and my current favorite is Conductor. It's created by a company called Blue Line Labs, and it's has a very simple life cycle, has easily customizable transitions, including shared element transitions, so you don't need an activity or fragment to be able to take advantage of those nice transitions. There's easy state persistence, since you have access to the activity bundle at every point in every controller if you wish. And controllers are the building blocks. They're analogous to fragments. And they are basically wrappers around view inflation, which really is what fragments are. The benefits to them is that they have the simpler life cycle. They still have those callbacks for permission results and activity results, so they're very similar to fragments in that way. I personally don't use those. I still like to keep that logic split out, but they're there if that's what you're used to. And like I said, their benefit over fragments is a highly streamlined life cycle. So here on the left, we have a controller life cycle, which is the white boxes. So we have five events. And on the right, we have the fragment, which is 11 events. And like I said, you can, if you use fragments, and many probably do, you get used to it, you know what you need to do, but this is still, in my opinion, overly complicated and unnecessary. The router is the analog to the FragmentManager, so that is your interface to the controller backstack and Conductor. It coordinates the pushing and popping of controllers, and it also it takes in router transactions, which define or can define transitions. So a very simple transaction would look like this. You would just say basically router push, and then this would be the argument you pass in. You tell it which controller you're pushing. You say which transition you want for pushing and which transition you want when that controller is popped. And that is all persisted. If your app is killed in the background, even your transitions are saved. Everything is rebuilt from a bundle, which is nice, and that part of it's taken care of for you. So overall, it's a very similar pattern with Fragments and FragmentManager. The main benefits are the extremely simplified life cycle. I think that transitions are much easier to customize, in my opinion. And again, I personally have not received one illegal state exception when working with Conductor, so that alone puts it ahead of Fragments for me. Some other options which I haven't personally used, but I wanted to mention because I can never give a talk without mentioning a Square library. Flow is a backstack management library, and you use keys, which themselves aren't even, it's not even an interface, I don't think. It's basically a class that just needs to have two string hash codes and equal overridden. You get full control over the backstack. So one advantage that people will say to using multiple activities is you can enter an application from an activity that's normally deep within the navigation hierarchy. And you can do that with all these custom backstack managers. So if you want to have a link that goes deep in your app from Google search, and you want to maintain when they click back, it'll actually go back through a virtual backstack. Not virtual, but it's a backstack that wasn't organically created. You can do that very easily with Flow, with Conductor, with any of these that you build. So that, in my opinion, is not a benefit from using multiple activities or fragments. The downside that I've read about Flow is there is quite a bit of boilerplate to set up. So it's probably slightly better than writing backstack management on your own, but it's definitely nowhere near as easy to get started as Fragments or Conductor would be. And then Scoop is another one that's been gaining some popularity kind of recently. It's developed by Lyft, and it's backstack management, so there's not as much boilerplate as Flow to set up, which is nice, but it also integrates scoping for you. So this kind of goes back to what I was talking about if you're building your own backstack management solution. It uses scoops, which are basically just scopes, and so it combines backstack and scope management into one library, which is nice. With Flow from Square, they use Mortar to do that for them. So sometimes you use a separate solution, sometimes not, but that is there for you. And again, I haven't personally used Scoop, but looked interesting. And I did want to, I have these links all to GitHub, but they're pretty easy to find, and obviously the Fragment docs are pretty easy to find on Google Developer website, but I did want to show, oh yeah, that's over here. So Conductor has a pretty nice sample app to just show all the possibilities. There's a lot of built-in transitions, so there's slide, there's circular reveal, fade, flip, and that's just another slide. And so this is an example of shared element, and it's very easy to build and implement. So you really don't lose anything going with Conductor over Fragments that I can think of. Yeah, that's about it. It also has an example of master detail. So that, again, I don't know why. I mean, Fragments aren't required for that. You rotate, you can load a landscape version of your layout and put controllers in the right containers. It's the exact same way you do it with Fragments, so Fragments aren't giving you anything extra there. And to be completely fair, I haven't used Fragments for a while, so I know they gave a talk at I/O saying how the API was getting better, but I'm perfectly happy with Conductor now, so I see myself sticking with that. And at work, we use our own in-house built backstack management. So I probably won't be using them soon, but I'm just wanted you guys to know that there are alternatives. Yes.
But you said that inside of these, I think called view controllers or whatever you call them, controllers, that you had access to like permissions and that kind of stuff. How does that even work?
So,
do you need access to the fragment activity for that?
Well, the funny thing is, Conductor uses a fragment to hold all its state, but it's a headless fragment, like with retain instance state and stuff. So it actually instantiates a fragment when you first attach the router to the activity, and it attaches itself to that. It calls it the lifecycle handler, and it receives all event callbacks through that.
So they need to support anything that you're going to support. Does that make sense? Like they need to build stuff specifically to work with permissions, or is that?
They did, yeah. I mean, they put that in. It's built into the base controller. Basically, if you request permissions from a controller, that controller is flagged as receiving permission callbacks. I don't personally use it because I like keeping my controllers, fragments, activities, whatever dumb, and I usually have separate classes that handle that. But if you say start activity for result from a controller, that controller will receive the activity result. If you request permission from a controller, that controller will receive permission result. And it does that all through a headless fragment.
So would you be able to like add additional functionality, like let's say, I don't know, requesting like location requires access to the activity or fragment? Would like anything work with that?
You do have access to the lifecycle handler. I haven't seen what everything is exposed on that. And again, the lifecycle handler is the fragment. I don't know what all is exposed. I haven't dug that deep because I've really tried, especially as I moved away from Google provided like UI stuff, to have everything split out. My controllers basically inflate the view and pass events on to my presenter.
Can you go back to the slide that shows the, it's early in your package.
This one?
Keep going back.
Was it a picture?
Yeah.
That's
that
back?
one. That one. That's one of my homework assignments.
Oh, okay.
And what you're saying, I think what you're saying is that that can be done without the use of fragments.
Mhm. Yep, so basically all you do here is, or at least like with a controller, when you inflate your layout, if you define your details container as nullable, this is how I would do it. Google has docs that are a little more involved. They basically set a flag at the beginning is dual pane. But what I would do personally is I would have a list container and a details container, which are just frame layouts that are waiting for you to shove a view in them. And if details container is not null, when I click on something from the list container, I push the detail controller, fragment, whatever, to that detail container. If it is null, I know I'm in a single pane view, so I will either push a new fragment. In Google's docs, they say start a new activity. But yeah, there's a few ways to do it, but I think the easiest is really just to check if your second container is present. And if it's not, then you overlay your current view. If it is, you put your details view in that second container. So yeah, the way they do it is not short. I wonder if I can find it quickly.
Actually, I got the idea for that assignment from a book written by a guy named Led Mackey. It's called Smashing Android UI. And there's probably more up-to-date books.
Yeah.
It's free and it's online.
Okay.
So
Let's see. Any other questions while I try to find this?
With the differences between like unfiles and unsound fragments, is there a way to do that with any of the libraries or single views, especially with still getting more for that?
So you get, where's that left? I'm wondering, yeah, I haven't experimented with what callbacks we get in the controller for that. You can register, this I do know, and this kind of answers your question, but not really as far as location goes. You can register for like full lifecycle callbacks if that's important, which in that case it definitely could be with the new dual or the multi-window and stuff. But going back here, basically it is defining dual pane. Oh, so it is basically just checking if the details frame is null. And then when you click, it is just using the FragmentManager to replace the fragment or add in that container. So this is the details container view ID. Otherwise, it is just starting a new activity. Which, in my opinion, I still don't know what Google's desire is as far as like fragment to fragment when to do new activity versus just, because you can just make a backstack of fragments and have a single activity. Again, what I hear a benefit is you can do deep linking into your app, into what would normally be the third or fourth activity in your backstack. And just by doing that, since you define activity parents, when a user clicks back, they'll go back through a backstack that they never initially created, which is fine, but you can do that with even fragments, I think, though maybe not as easy as like Conductor or some of these third-party libraries where they allow you to build a backstack from scratch. Anything else? All right, thank you.